Have you ever just stopped and wondered, what are the actual fundamental rules of our universe? Well, today, we're going to try and figure them out. And you know what? All we're going to need is a little thought experiment.
So, picture this. Just two marbles, that's it. They're floating in a totally empty void. Nothing else around. They're just moving in perfectly straight lines at constant speeds. Now, how in the world would we even begin to describe what's happening here? It sounds simple, right? But believe it or not, this little scene, it holds the key to understanding, well, pretty much everything.
Okay, so before we can really describe our marbles, we need a way to talk about numbers. And I mean the really, really big numbers and the impossibly small ones. So the first piece of our cosmic puzzle is all about the idea of scale.
Let's just say, for example, we have 1,000,000 marbles. You know, writing out all 6 of those zeros is already getting a little clumsy. You can see how this would get out of hand fast. We definitely need a better system for this.
So we get clever. We invent prefixes. We can just group 1,000 marbles together and call that a kilo marble. Simple enough. Then if you take 1,000 of those, you get a mega marble, and hey, that's our 1,000,000 right there. Then 1,000 mega marbles is a giga marble, and you can see where this is going. Each step is just 1,000 times bigger than the one before it. It's a really powerful but simple way to handle these gigantic quantities.
And of course, this whole system works in reverse, too. It's not just for big numbers. We can divide by 1,000 again and again to talk about teeny tiny fractions. We go from milli down to micro, nano, and even way beyond that. It's the exact same logic, just for things that are incredibly small.
All right, so now we have a handle on how to count things. But what are we actually measuring out there in our void with the two marbles? Well, to describe their reality, we're going to need to define 3 really fundamental concepts: space, matter, and time. First up, space. To know where a marble is, we need some kind of grid, right? Kind of like street addresses in a city. And the basic unit we use for that grid is the meter. But where did the meter come from? Well, it's a totally human invention. We literally just decided, as a species, that the distance from the Earth's equator to the North Pole is exactly 10 million meters. That's it.
And what's really interesting is that all our other common units, inches, feet, miles, they're all just different ways of chopping up that same fundamental meter. They're all part of these kind of arbitrary human-made systems that we've cooked up just to measure space.
Okay, next up, matter. How much stuff is actually in our marble? We call this its mass. You can think of it as its resistance to being pushed around, how hard it is to get it moving or to stop it once it is. Our unit for this is the gram, which, you guessed it, is another human invention. It's defined as the mass of 1 tiny little cubic centimeter of water.
Now here's a really crucial idea. Our marbles, just like you and me and everything else, are made up of countless tiny atoms. And for our purposes, these atoms behave just like tiny, identical marbles themselves. So what that means is the total mass of our big marble is simply the sum of the masses of all those little atom marbles packed inside it.
And finally, there's time. See, our marbles are moving, right? So their positions are constantly changing. Time is what we use to measure that change. You can think of it like a flipbook. Each page is a little snapshot, a single moment in time. The unit we use to label each of these snapshots is the second, and we defined it so that there are exactly 86,400 of them in one full day.
Okay, so we have our units for space, for matter, and for time. We've built a whole system to perfectly describe our 2 little marbles. And this is where the implications of our simple thought experiment start to get really, really profound.
Think about it. We could describe our marbles using meters, grams, and seconds. Or we could use a totally different system, maybe one with miles, pounds, and hours. The numbers we write down would all be completely different. But what about the actual physical behavior of the 2 marbles? Would they care? No way. It would be exactly the same.
And this tells us something huge. It means the underlying rules of the universe don't give a hoot about our man-made measurements. The physics just works. It points to this fundamental, mechanical reality that exists completely on its own, totally independent of us.
And now, here it is, the absolutely staggering conclusion. If our marbles follow these exact, predictable rules, and we are made of atoms, and atoms behave just like tiny little marbles, then doesn't it follow that we also have to operate according to these same predictable rules? From this viewpoint, our entire universe is just a giant cosmic clockwork machine, where every single thing that happens was already predetermined from the very beginning.
Wow. I mean, that's a pretty bleak and mechanical way to look at the universe, isn't it? A universe with no free will, no real meaning. But is that really the whole story?
I mean, if we follow this cold, hard logic all the way to its end, we have to conclude that everything, including us, is just a collection of atoms following these preset paths through a meaningless cosmic void.
Based on this classical mechanical view of physics, there really doesn't seem to be any way around this conclusion. It feels absolute, final. Just a sad but logical truth.
But is the universe truly just a predictable machine? Or is there maybe something more to the story? Something our simple model of two little marbles just can't possibly explain? Now that is the real question, isn't it?